Hello, my name is Jack Northcutt with team number 10, project 19, the solar system designer. The overall goal of this project and within these first couple weeks was to get everything set up and researched. So, which involved like creating a connection to our Smart Sparrow API, adding a Unity project to our GitHub repository with all of the appropriate APIs attached and libraries, improve our tool chain, build a basic mock-up UI, and familiarize ourselves with Unity because no one in the group has used Unity before or is very familiar with Unity and or C Sharp. And also, our group needed to research in-body physics and learn how to apply these different equations to our project. This was more of a research and to design the basic solar system objects such as like sun, moon, planet, etc. Just to get everything set up so we can easily bring everything together. Um, First, I'll show you from the outcome from the physics research um, I did myself, which is um, I researched different types of in-body physics and learned how to model an ellipse and wanted to see how we could do that programmatically. And so what I did was create just a few test classes and a bunch of functions testing different functionality of in-body physics and which involve Kepler's law and ellipse modeling. So these classes just model any. These files are for the purpose of demonstrating the research of the physics, and so we can later apply these methods to or these same types of functionality to our planet objects later in space. So first, I have an ellipse construction. This is basically a bunch of different functions to test a few different things on ellipse modeling. So first, we'll give it a length of 20. We'll say 10. What is the angle of your planet from the sun? So this is basically a focus. The ellipse has two foci, and one of the foci would be where our sun is placed, and the angle would be from there to the planet. So we'll say 30. And your x position. This is so we can determine by a given x position of a planet on the ring of the ellipse, we can determine its y position as well. And so we'll give it 7. And you can see here, I calculate the foci. So the foci points are 8.6 from the center of the ellipse. The eccentricity is a value that's used in a lot of different in-body physics equations, and this is basically the how stretched the ellipse is. The closer to 1, the more stretched. The closer to 0, the more circular. And then it shows that our planet that we created is 10 from the sun. This is the distance between the added foci to the planet. And your planet's position is 7, 9. So this represents a coordinate of where the planet would be in a 2D plane. Next, I'll show you another class I made to test Kepler's third law, which has to do with different masses and the distance between planet and sun, and getting a value of how many days it takes to make one revolution is based on a distance in astronomical units. And for example, I can show you that Mars is 1.524. So we'll enter 1.524 for, and it will take 686.7 days to rotate, orbit around the sun, and round that up is 687, and we can see here that it takes 687 days. So this will be great for our project and modeling different times of orbit. Next, I'll show you here. Tim created some mock-up UI designs, and we know the color scheme is off and it's hard to read at first, but this mock-up design is basically showing what our basic UI would look like. You could select the menu, information settings, selecting a planet, adding the size of your planet, the eccentricity value, or etc. And another photo. And here's where you could actually select sun, star, planet, moon. And it's just a basic mock-up, and the sponsor has seen our mock-up design already. And in our Google Drive, we've been storing a lot of information we find, such as I found some things about certain tasks we had in physics, and added a bunch of links from what I found useful. Some element charts. Liz actually created a Unity documentation. Since we all struggle with Unity, Liz did a lot of research in Unity and how to set it up. So she made a well-documented form, step by step, on how to do different things within Unity and set it all up. Excuse me. Josh worked on setting up our initial GitHub repository, making sure all of the libraries were where they needed to be, and helped everybody get their Unity set up. He also built the basic connection to Smart Sparrow API, which is shown here, but you can't really test it out yet. Josh also did the modeling of the planets, so created planet objects that we also cannot show at the moment, just because the planet objects are not applied to anything yet, so we can't really test these quite yet. But he did run a unit test and learned how to integrate that. And you can see in this picture here, he took a screenshot of running a test on his in-body test here, distance, and got that set up so we can now make sure we're constantly testing our project. And that is it. Thank you